In this example, we're going to learn how to find the GCF and LCM using Venn diagrams. Use the factor trees below to represent the prime factorizations of 24 and 60 in a Venn diagram. That's our first goal. And then we're going to use the diagram to determine the GCF and LCM. So first let's talk about how we're going to create a Venn diagram. So this is the beginning of a Venn diagram that we're going to fill in. It has three distinct parts, or three disjoint parts. This one, this one, this one. And we're going to see how we're going to use this information to fill in this to see which goes in what spot. So let's start with 24. So we're going to draw a circle for 24. And the circle is going to contain the prime factors of 24 from the prime factorization. So notice there's 3 2's. You need to include all 3 of them. So 3 factors of 2 and a factor of 3. Now for 60, we have 2 factors of 2, a factor of 3, and a factor of 5. So let's see what factors they have in common. Well, this 2 can correspond to this 2, this 2, and this 2, and this 3, and this 3. So their intersection, what they both have in common, is 2 factors of 2 and a factor of 3. And that's represented in this centerpiece of the Venn diagram. So we're going to say that this circle is all the factors of 24, the prime factorization of 24, these numbers put in one of these 2 spots, and this is going to contain the prime factorization of 60. Well, the overlap is going to be the prime factors that 24 and 60 share. So we're going to put 2, 2, and 3. Now looking at 24, the only factor we didn't include in this intersection is this number right here. So that goes on the outside. This is an additional factor of 24 of 2 that 60 does not have. They share 2, but 24 has 3. And over here, the only piece that's missing is a 5. So 60 is 2 times 2 times 3 times 5, which we have over here. 24 is 2 times 2 times 2 times 3. So this is how we create a Venn diagram representing these relationships. Now let's find the GCF and the LCM. So notice that 24 and 60, if we look at these, 2 times 2 times 3, these are the factors that they have in common, okay, that we put in here. So 24 is equal to 2 times the product of these numbers, which is 12, and 60 is equal to 5 times the product of these 2 numbers, which is 12. Well, notice that we know, so they both have a factor of 12, and 2 and 5 don't share any common factors besides 1, because they're prime. So that means that 12 must be the greatest common factor. We can't pull any more factors out of these numbers to make this larger. So that means to find the GCF, you just need to find the product of the numbers in the center. So the GCF is 2 times 2 times 3, which is 12. Now let's think about the least common multiple. Okay. Well, we know that multiples of 24 will have some number, 1 times 24, 2 times 24, 3 times 24, etc. That's how we find multiples of 24. And to find multiples of 60, we multiply some number times 60. So 1 times 60 is 60, 2 times 60 is 120, etc. Now, we know we can multiply these numbers to find a common multiple, but we want a least common multiple. So we're going to use this idea. Well, 24 is equal to 2 times 12. So that means the LCM is some number times 2 times 12. And similarly, 60 is 5 times 12. So the LCM will be some number times 5 times 12. Some number times 5 times 12. And we want to use the least amount of factors. Okay? So if we need some number times 2 times 12 and also some number times 5 times 12, notice they have the 12 in common. We just need to include both 2 and 5 in the LCM. So I'm going to write this over here. The LCM is going to be 2 times 5 times 12. And let's just highlight why this is the case. So if we have 2 and 12, well, that means it's definitely a multiple of 24. It's 5 times 24, so that checks. And if we have 5 and 12, then it's 2 times 60, which is definitely a multiple of 60. And we use the minimum amount of factors because we only included what was missing in each expression right here. Now notice the way you can find this using the Venn diagram is to include every number you see here once. So these greatest common factors, this 12, we only needed to include that once, so not all of them in this list. Okay, we don't have to repeat the 2, 2, and 3 twice because including them once gives us the least common multiple. So we have that it's 2, I'm just reading from left to right, 2 times 2 times 2 times 3 times 5, and that is 10 times 12, which is 120. Okay. And your packet summarizes these ideas.